x plus 4. Okay, so now I'm going to multiply through and try to collect like terms. Well, one step at a time, I guess. So ax squared minus ax minus 2a plus bx plus b plus cx squared minus 4cx plus 4c, good grief, over the denominator x minus 2 quantity squared times x plus 1. Okay, so collecting like terms, I end up with, there's a squared term here, there's this other one, factoring out x squared from those, I end up with a plus c times x squared. Okay, next I'm going to look for all the terms that have an x in it. There's 3 of those, and I'm going to factor out the x from those 3 terms, and I end up with minus a plus b minus 4c times x. Then I have to account for all the constants, which are minus 2a plus b plus 4c. And this is still divided by our standard denominator, x minus 2 quantity squared times x plus 1. Okay, time to move on to the next page. So I'm just going to recopy the numerators. So on one side we had 1, right? That was the numerator of the original fraction, if you recall. Right here, that's the lovely 1. And now I'm going to have and try to remember here that the numerator that we ended up with in terms of these constants a, b, and c are a plus c times x squared, excuse me here, minus a plus b minus 4c times x, and then we have minus 2a plus b plus 4c. Okay, so if you remember, basically we wanted the two fractions to equal, just like in the earlier cases, and we wanted to, basically we want to make this happen by setting the numerators equal to one another. And now we're going to look at the left-hand side of this equation, the 1, as actually a polynomial. So since there's no x term on the left-hand side, that means that the coefficient of the x term on the left-hand side is 0. Now we want the coefficient of the x squared term on this side to be 0 as well. So that means that a plus c must add up to 0. Because otherwise we would have an x squared term on here, and we don't want that. Now there's no x on the left-hand side, so we also want minus 4a minus a plus b minus 4c to add up to 0 as well. And then the constant term, minus 2a plus b plus 4c, so minus 2a plus b plus 4c should equal 1. So here we go. We have 3 equations, 3 unknowns, and just for the heck of it, I'm going to go through and solve this. So note the following. A should equal negative c from the first equation. I just subtract c from both sides. Now I'm going to take the bottom equation and I'm going to replace a by negative c. So this is the two equations I'm going to end up with. Minus c plus b minus 4c should equal 0. The second equation is going to be minus 2 times minus c plus b plus 4c should add up to 1. So this is now, I use basically the substitution method to convert my 3 equations and 3 unknowns into 2 equations and 2 unknowns. And so, let's see, I end up with b minus 5c equals 0. And in the bottom, I have a 2c plus 4c. That makes this a b plus 6. That should be a 6c should add up to 1. Okay, so it looks to me that maybe the easiest thing will be to actually use a substitution method. So I'm going to solve for b in the first equation. Turns out b should equal 5c. Now I'm going to plug this into the second equation. So b, which is 5c, plus the 6c should add up to 1. So 11c equals 1. So c equals 1 over 11. Okay. Now if you recall, a was equal to negative c. So this tells me that a is minus 1 over 11. And just to check here, b was equal to 5c. So b is equal to 5c, which will make this a 5/11. Okay, so we have our constants for our partial fraction decomposition, where c is equal to 1 over 11. So the meaning of these constants, and I'm going to check the setup that we had just so that I will use the right constants for the right fractions. Turns out, here we go, that 1 over x minus 2 quantity squared times x plus 1 can be written as the sum of minus 1 over 11 over x minus 2 plus 5 over 11 over x minus 2 quantity squared plus 1 over 11 over x plus 1. And that's it.